In this lecture, we're going to talk about selection. I call it selection. It's the if-then-else structure. Basically, you want to be able to have your programs respond to user actions and user input and data input. And there's two mechanisms to do that. One is by turning on and off pieces of the program. You're basically selecting what parts of the program to run. And the other is through repetition. This lecture talks about selection. The next one talks about repetition. So we're going to learn basically about basic blocks of code, talk about the three things that are required for all if-then-else or selection constructs, regardless of the language, and then talk about how to code these things up in Java. Okay, 5 parts, just computation. Again, remember, we talked about declaration and assignment previously. We'll talk about selection now. We'll do repetition later. Input and output we're kind of folding in throughout the camp. Okay, so basically, selection allows you to select which pieces of code will or will not execute. This is not a standard term. This is really more my terminology. People, you generally talk in terms of if, then, else. If this, do that. If this, then do that, else do some other thing. Why do you have it? Again, you have to have it because this is how a program responds to user input. If you were playing a game and the game did not respond to your input and always did the same thing over and over again, it would be basically useless. Allows you to change the behavior. And how do you know when you're going to use these? You know these when you're talking through and you actually use the terms if, then, else. Well, if this is true, then I have to do that, or else I'll do something else. If I'm hungry, then I will eat, otherwise I won't. If I have food, then I will eat, otherwise I won't. If I have enough money, I can buy that thing that I was looking at in the store, else I won't. This is the basic if-then-else form. Other forms do exist. There are fancier ways to do if-then-else, and we'll talk about some of those later on in the camp. But basically, anything you can do with the simple if-then-else, you can do with all these other forms. They exist to make life easier for the programmer. Okay, what does an if-then-else need? There's 3 things needed. Always 3 things needed. One is a Boolean test. What is a Boolean test? It's an expression or a test or a question that evaluates to true or false. So you can't say, how many legs does a horse have? Because that answer is 4. But you can ask, does a horse have 4 legs? And that would evaluate to true most of the time, right? Does this specific horse have 4 legs? Almost always that's true. I have met 3-legged horses in my life, so it can be false. Then, once you set up this test that's going to respond with either true or false, then you set up something to do if the test is true. We call that the true branch. And then you set up something to do if the test is false, the false branch. That's all you need to remember, those 3 things. A Boolean test that returns true or false, something to do if it's true, something to do if it's false. The rest is simply formatting, and different languages will have different formats for these things. So in the center there, Java and C, they've all come to the same conclusion for what their tests will look like. It will look like that. It literally is the word if, lowercase I, if, parentheses with a test inside, curly bracket, whatever you want the true branch to do, close the curly bracket, the word else, open curly bracket, whatever you want to happen when the test is false, and then close the curly bracket. They're all the same. Other languages, like I said, will do things a little bit differently. MATLAB relies more on line feeds. Python relies on line feeds, not curly brackets. I like having the curly brackets here because it's a real clear marker as to when things start and stop. So that's what our if-then-else test will look like in Java. Okay, what about these Boolean tests? What can you do? Basic tests. And we're going to do these throughout the camp. We'll not as likely get into these more complicated ones on the bottom. You're asking, is A equal to B? Again, it's not a statement, it's a question. Is A equal to B? Well, we've already used the equal sign. If we said A equals B, what does that mean? Remember from assignment, it means that you go to the place where B is, grab that value and give it and store that value in A. Well, we can't reuse the equal sign, so it's a double equal sign. A equal B. You're asking the question, is A equal to B? And that's either going to be true or false. Right? Yes or no, true or false. What if you wanted not equal to B? You do A exclamation point B. The exclamation point is called the not operator. So you literally can read that as A not equal to B. And then the rest of these I think you've seen in your algebra class or something similar to it. A greater than B. A greater than or equal to B. Well, we don't have the special line that you used in math class with the greater than sign with the line under it. That's not on your keyboard, right? So it's the greater than sign with the equal sign following it. And then, of course, A less than B, A less than or equal to B. Those are the basic tests. And when you need to do a particular one and you can't remember what the formatting is for it, come back to this page and take a look. If then else, here's our standard form, right? If Boolean test. What's the Boolean test? X greater than Y. Again, we're not claiming that, we're asking the question, is X greater than Y? And that's going to say true or false. And then inside the curly brackets, we do something. If X is greater than Y, we print out the word yes. Else, we print out the word no. So if X is greater than Y, we'll get a yes on the screen. If X is not greater than Y, in other words, equal to or less, then we get the word no. This is a silly example. So we're following our form. Boolean test, something to do if it's true, something to do if it's false. Sometimes you don't want something to happen if it's false. If X is greater than Y, do something, otherwise don't. Okay, you just leave that false branch out. It is absolutely legal to do the opposite. If X is greater than Y, do nothing, else do something. It's absolutely legal. This will compile, this will run, never do it. Always make the true branch the one that has the action. How would you fix this? Well, instead of X greater than Y, you would change the test. If X is less than or equal to Y, then the true version of that is going to be the same as the false version of X greater than Y. We can put these inside of each other. So remember, if X is greater than Y, do something. Oh, we didn't restrict what we could do. We can do anything in there, including another if-then-else test. So you can have these nested. As a general rule, the most you're going to nest is two, like this, one inside the other. If you start doing a whole bunch of nesting, where you've got an if inside an if inside an if inside an if, it probably means that you have bad design and you should rethink it. But sometimes, every now and then, you just can't get away from it. A version of this, I told you there were versions of this. We can do everything with the if-then-else. There are versions that make life easier for the programmer. It's called the else if. So if X is greater than Y, do something else. And now we put another test in there. If X is greater than Y, print out yes. Else if X is greater than Z, print out the Y. Else if X is greater than P, we can keep adding these. Print out Y not. And if none of those are true, we'll print out no. We don't do this too often. I find that in my programming, the basic if then else works out just fine. And sometimes I have to nest it. Switch statements I'm not going to talk about now. We'll talk about them later. Again, it's a way to simplify. It's a way to simplify a bunch of complicated if-then-elses, but we don't have a need to talk about this just yet. And lastly, again, I'm putting it in here for completeness. We don't need to worry about it too much. You can combine Boolean tests. Sometimes you need to have, like I'm going to order, I'm going to go get a pizza. Okay, I need gas in the car and I need money in my pocket. Both of those have to be true in order for me to go get a pizza. So you have ways by which you can combine these things. And the basic combination for the AND is the double ampersand. The OR is a double vertical line. We don't do this too much. We will rarely do this during the camp. Go back and just remember that basic form. And the basic form is going to cover, 90–95% of your programming needs. That basic form right there. That's going to be the thing that you need, again, 90–95% of the time. All right, on to the next.